The first topic on this unit, or this section of the unit, is multiple representations. So on our graphic organizer, we're going to write slope in the concept, or on the concept line. We're going to look at how slope shows up in various forms. So the first one we're looking at is verbal. If you see the words rate of change, unit rate, per, or at a rate of, those are all talking about slope. When you graph a line, we talk about rise over run. So let's say we have a graph that has a slope of -3/4, and we're going to start at the origin. This means that I would fall 3 and run 4 and make a point, fall 3, run 4, make a point, and then connect the dots or the points with a straight edge. So our slope shows up with these similar triangles showing our rise over run. We show slope symbolically through, instead of writing rise over run, we write change in y over change in x, and those triangles mean change in. They also mean that we're looking at the difference between y values and x values. Algebraically, we have a formula for slope that means change in y over change in x, and that is y2 minus y1 equals x2 minus x1. And finally, slope shows up in tables as well. So if I have this table, normally we look at it like 0 to 1 is 1 and 2 to 4 is 2. But when we're dealing with slope, we're looking at a horizontal relationship. What did I get to the 1 to get the 4? And most people would say, well, you added 3, but not in this case, because I'm going to go back and look at the 0 to 2. I didn't add 3 there. I took 0 and I added 2 to it. So there's got to be something else going on. So we're going to do 1 times 2 plus 2, that's 4. Now let's see if that works for 2 and 6. 2 times 2 is 4, plus 2 is 6. And 3 and 8. 3 times 2 is 6, plus 2 is 8. And so all our slope in this case is showing up when we multiply each of our x values by 2 before adding. And we're really doing that in the first one too. We're doing 0 times 2 plus 2. So underneath your purpose, go ahead and write this down. We're going to work Sarah's problem. She earns $100 per week, say babysitting, and then at another job, she earns $10 per hour. So maybe she's working at a grocery store somewhere. That's really good payment for grocery store working. But this is the information. All of this right here is how we would express the situation verbally. Okay? We have $100 per week, $10 per hour. Those are rates of change. If you look at a table for this situation, if we list our hours under the X and the amount of money she makes under the Y, for 0 hours working at the grocery store, she still makes that $100 from babysitting. But if she works an hour at the grocery store, she has a total of $110. If she works 2 hours, she has a total of $120. If she works 3 hours, she has a total of $130. And if she works 4 hours, she has a total of $140. So this table represents that situation that was explained in words or verbally earlier. The X represents the number of hours, and the Y is the dollars or the amount of money that's earned. So we can take this information and we can write it algebraically by defining our variables. X equals number of hours, Y equals money earned, and then writing an equation. So the money earned, or Y, equals 10, because that's what she's getting paid per hour, so it's 10x, plus the $100 that she starts the week off from babysitting. 10 is your slope, or your rate of change, and 100 is your starting point. Then we can look at this symbolically. We can say change in y over change in x is the same as the change in money over the change in hours. As the hours she works increases, the money she earns increases. And finally, we can look at it in terms of a graph. So I'm going to say that my x-axis goes to 10 and goes from negative 10 to 10, and my y-axis goes from negative 1,000 to 10,000. We start with her at $100 for 0 hours worked. And then for if she was to work 10 hours, she would get another $100. So her line graphing the relationship would look something like that. So as time goes on, she's making more money.